Assalamu alaikum my dear students, how are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NI EVS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School, Day Shift. Today I am going to take a physics class for class 10 students. My dear students, our today's topic chapter 10 discussion part 2 and today's lecture number 2 and SW number 1. My dear students, let's start our class. This is chapter 10 static electricity and our discussion. This is discussion part 2, discussion number part 2. Okay, in this class we will discuss about electric force, that is Coulomb law. We will learn the Coulomb law and we will solve some mathematical problems about Coulomb law. Now electric force, we have seen earlier that opposite charges attract each other and similar charges repel each other, but we don't know about we do not know yet how attraction or repulsion works, and to know this we need to look at Coulomb's law. Coulomb's law. So what is Coulomb's law? In Coulomb's law we have to consider two charges. Suppose this is charge q1 and this is charge q2 and the distance between two charges are r. Okay, this r is the distance. So now we have already seen that Newton's gravitational law, force law, and we know that formula, the Newton's gravitation formula was F equals to G m1 m2 divided by r square. Okay, this is the Newton's gravitational law, and from Coulomb's law also similar like this. Just here m1 will be q1 and m2 instead of m2 it will be q2. That is, for m1 instead of m1 it will be charge q1 and for m2 it will be charge q2. So from this now we can see that from this law we can see that it will be here another constant. This is Newton's gravitational constant and it will be another constant. This is k q1 q2 divided by r square. This is the Coulomb's law. So my dear students, now we will give a statement of Coulomb's law, that the force of, we can say that like this, the force of attraction or repulsion between two charged bodies in particular medium is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them, and the force acts along the straight line connecting them. So my dear students, from this equation we can see that F is proportional to charge q1 and q2 and F is proportional to the 1 divided by r square. So from this formula we can see that the force of attraction or repulsion between two charged bodies in a particular medium is directly proportional to their product of their charges, and it is also directly proportional to the inversely proportional to the square of the distances. This is the Coulomb's law. My dear students, now see here k, this is the another this is constant k, and the value of constant k is, the magnitude of constant k is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, and we know that Coulomb is Coulomb is the unit of charge. Okay, my dear students, now come to next topic, that charge of, we have already learned this one, charge of electron is minus 1.6 into 10 to the power 19 Coulomb and charge of proton is 1.6 into 10 to the power 19 Coulomb. The charge of proton and electron is equal but opposite. Okay, and from this discussion we can say, we also see that if charge q1 and q2 both are positive or negative, then the value of F will be positive or will repel each other. See, if the charge q1 is positive and q2 is positive, then force F will be positive. If charge q1 will negative and q2 will negative, then force also will be positive. And if charge q1 is positive and q2 is negative, then force will be negative. So that means opposite charge always this charge, if charge q1 is positive and q2 is negative, then the force will be negative. That means they repel each other. Okay, my dear students, now we will solve some mathematical problems. Okay, here see the question number 1, problem number 1. This is problem number 1, and we can see the question. Plus 1 charge and minus 1 charge are placed at a distance of 10 centimeter. How much force is acting between them? Now we'll solve this mathematical problem. See, here given plus 1 charge, Coulomb charge, plus 1 Coulomb charge and minus 1 Coulomb charge. Suppose this one is plus 1 Coulomb charge and this one is minus 1 Coulomb charge, and the distance between these two charges is 10 centimeter. Okay, we have to find out the force between them. We have to find out the force between them. So we can write here, given charge Q1 equals to plus 1 Coulomb, Q2 equals to minus 1 Coulomb, distance R equals to 10 centimeter, and we have to convert this centimeter into meter. That means 10 divided by 100 meter, and it will be 0.1 meter. We have to find out the force between these two charges. So force equals to what? So from Coulomb's law we know that F equals to K, Q1 Q2 divided by R square. Now put the value. Now K means, we know that K means 9 into 10 to the power 9 Newton meter square per Coulomb square. Sorry, Newton meter square per Coulomb square. So write 9 into 10 to the power 9 into Q1 means plus 1 into Q2 means minus 1 divided by R square. R means 0.1 whole square. So by doing this calculation, this is plus and minus. Plus and minus will be minus, and by doing this calculation we will get the value minus 9 into 10 to the power 11 Newton, 10 to the power 11 Newton. The charge of force is Newton. Okay, my dear students, now I hope all of you have understood this mathematical problem. This is very easy mathematical problem. Now come to next mathematical problem. Now I will solve number 2, mathematical problem number 2. Okay, this one, problem number 2. Okay, here given, see the question. Two charges of plus Coulomb and plus 5 Coulomb and plus 3 Coulombs are placed at a distance of 1 meter. My dear students, first of all we have to draw the figure. We can plus 5 and plus 3, and the distance between these two charges is 1 meter. Okay, 1 meter. According to the question, the distance between two charges is 1 meter, and now a third charge plus Q is placed in between them. Where will it feel any force? Where will it not feel any force? Okay, my dear students, suppose the distance, this is plus Q charge. Suppose this one is plus Q charge. Suppose the distance between 5 Coulomb charge and between plus Q charge, distance between these two charges is x. Okay, suppose these two the distance between these two charges x, so it will be the distance between plus Q and plus 3, this charge will be 1 minus x. So 1 minus x. Okay, the distance between this plus Q charge and plus 3 charge will be 1 minus x. Now we have to find out that in which distance the plus Q charge will not feel any force. So my dear students, the plus Q charge will repel the plus 5 Coulomb charge will repel plus Q charge towards this line. Okay, this towards this line, that means in right, and the plus 3 charge repel towards left side. Okay, then when two charges will repel equal force, then plus Q charge will not feel any force. Okay, now from Coulomb's law, we have to find out the force between plus 5 Coulomb charge and plus Q charge. Okay, between these two charges we have to find out the between these two charges force. Okay, so the force will F will be, from Coulomb's law we can write that F equals to K Q1 Q2 divided by R square. Here Q1 is plus 5 Coulomb and Q2 is this plus Q charge. Okay, so now write the value f, put the value k into q1 means plus 5 coulomb charge into q2 means q divided by r square. Here r means x square. Okay, here this between these two charges distance is x, sorry r equals to x meter. Okay, so it will be x square. Okay, this one is suppose this one is equation number 1. Then we will write the force between this plus coulomb charge and plus 3 charge. The force between plus coulomb charge and plus 3 charge will be F equals to K. Q1 means plus 3. Q1 means plus 3 into Q2 means Q divided by R square. R means 1 minus x. Okay, 1 minus x whole square. So suppose this is equation number 2, and from according to question we can say that when two charges will repel equal force, if the force will equal, then the plus q charge will not feel any force. So we can, from these two equation we can write that the force will equal, so we can write that k into plus 5 into q divided by x square equals to plus 3 q divided by 1 minus x whole square. Now we can write the simple equation k q vanish. So 5 divided by x square equals to here 3 divided by 1 minus x whole square. Okay, my dear students, now 5 into 1 minus x whole square equals to 3 into x square. Now write this one is 1 minus x whole square, that means a minus b whole square formula. Okay, use a minus b whole square formula. So 5 into a minus b whole square, that means a square minus 2ab plus b square equals to 3x square. Now do the mass multiplication. 5 minus 5 2s are 10x plus 5x square equals to 3x square. Now side change, just 5x square minus 3x square. So it will be 2x square minus 10x plus 5 equals to 0. My dear students, now see, we can see that ax square plus bx plus c equals to 0. Okay, just similar this equation. See, here a is 2. Okay, a x square minus bx, so it will be plus bx. So here minus 10 will be b. Okay, minus 10 will be b. Okay, then and c means 5. Okay, so from this equation we can see that a equals to 2, b equals to minus 10 and c equals to 5, right? Okay, now from this equation we have to find out the value of x. So from this equation, from this formula, we have to use this formula bx equals to, from this equation, this formula we have to use x equals to minus b plus minus root over b square minus 4ac divided by 2a. So by using this formula we can find out the value of x. So my dear students, now we can write x equals to minus b, that means b means minus 10. Okay, minus b, that means b means minus 10. So minus into minus 10 plus minus b plus minus root over b square. B means minus 10 whole square plus minus 4ac. Sorry, it will be minus 4ac. 4 into a means 2 and c means 5 divided by 2a. 2 into a means 2. Okay, now x equals to, do the calculation. minus plus 10 plus minus root over 10 square, that means 100, minus 5 2s are 10 and 4 10s are 40, divided by 2 2s are 4. My dear students, now do this calculation. 10 plus minus root over 100 minus 40, that means 60, divided by 4. My dear students, now see from here we have to calculate the two values. We can find out the value of x like this. X equals to 10 plus 60. If we consider plus, then you can write like this, and if we consider minus, then x equals to 10 minus root over 60 divided by 4. So from this calculation we can say that x equals to 4.435, and this from this equation we can see that x equals to, the value of x equals to 0.565. Okay, my dear students. So that as the value of x will be between 0 and 1, as the value of x will be between 0 and 1, so the value of x is acceptable. Okay, this is acceptable. So the answer of x will be 0.565 meter. Okay, so at 0.565 meter, the force will not feel any force. Okay, now come to next mathematical problem, number 3. Problem number 3. My dear students, I hope all of you have understood this mathematical problem, and practice. You have to practice at home all mathematical problem properly. Now come to next mathematical problem, number 3. Here question, this is number 3. There is a proton in the center of a hydrogen atom and an electron outside it. The charges of the proton and electron are plus 1.6 into 10 to the power 19 Coulomb and minus 1.6 into 10 to the power minus 19 Coulomb respectively. The charge of this proton is plus 1.6 into 10 to the power minus 19 Coulomb, and the charge of the electron is minus 1.6 into 10 to the power minus 19 Coulomb. If the distance of the orbit of the electron from the nucleus is 0.05 into 10 to the power minus 8 meter, how much attraction is found between them? My dear students, here given the charge of proton is Q1. Suppose charge of proton is Q1. So the charge of proton here given plus 1.6 into 10 to the power minus 19 Coulomb, and the charge of electron minus 1.6 into 10 to the power minus 19 Coulomb. The distance between them are equals to 0.5 into 10 to the power minus 8 according to question, 8 meter, and we know the value of K equals to 9 into 10 to the power 9 Newton meter square per Coulomb square. My dear students, we have to find out that how much attraction between them. That means F equals to what? From Coulomb's law, by using Coulomb's law we can easily find out. So F equals to, you can write F equals to K Q1 Q2 divided by R square. My dear students, now put the value. K means 9 into 10 to the power 9 into 10 to the power 9 Newton meter square per Coulomb square into Q1 means plus 1.6 into 10 to the power minus 19 Coulomb into Q1 into Q2. Q2 means minus 1.6 into 10 to the power minus 19 Coulomb and divided by R square. R means here given 0.5 into 10 to the power minus 8 meter square whole square. So by doing this calculation we can find that minus 9. The attraction force attraction will be minus 9.22 into 10 to the power minus 12 Newton. This is easy calculation. Okay, my dear students, now we will solve the mathematical question number 4. I hope all of you have understood this problem also. Okay, now we will solve number 4. This one is number 4. Okay, now see the question. How much charge should be stored in the earth and in the moon so that the gravitational force becomes 0 and the moon goes out of its orbit? My dear students, I repeat, how much charge should be stored in the earth and the moon so that the gravitational force becomes 0 and the moon goes out of its orbit? My dear students, the gravitational force acting between the earth and the moon will be Fg. From this gravitational law we can write this one, Fg, the gravitational force. Fg equals to G m divided by r square. Here given, here m will be the mass of the moon and m will be the mass of the earth, and r is the distance between moon and the earth. G is the gravitational constant. Okay, my dear students, from here we can see that we can write here G equals to, we know G equals to 6.673 into 10 to the power minus 11 Newton meter square per kg square. Mass of the moon is 7.35 into 10 to the power 22 kg. My dear students, you have to memorize this value. And the mass of the earth is 5.97 into 10 to the power 24 kg, and the distance between moon and the earth will be 3.84 into 10 to the power 5 kilometer. My dear students, all this value you have to memorize. Okay, now we will find out the gravitational force between the moon and the earth. The gravitational force between moon and earth. Now we will put the value G here given 6.673 into 10 to the power minus 11 into m. M means, my dear students, now I can write here G 6.673 into 10 to the power minus 11 into m means the mass of the moon, 7.35 into 10 to the power 22 into mass of the earth is 5.97 into 10 to the power 24 divided by r square. R means the distance between moon and the earth, 3.84 into 10 to the power 5 kilometer. Okay, it will be kilometer, so whole square. Okay, now by doing this calculation we can find out that it will be, the force will be 1.98 into 10 to the power 26 Newton. Okay, the gravitational force between moon and earth will be 1.98 into 10 to the power 26 Newton. Okay, now if an equal amount of charge is kept in the earth and the moon, the repulsive force will be, if an equal amount of charge is kept on the earth and the moon, the repulsive force will be, that means if the equal charge, that means charge q and charge q, the same charge, equal charge will keep in the moon and the earth, then the we know that same charge always repel each other. That means here repulsive force, we have to find out the repulsive force between them. That means Fe, repulsive force will be, from Coulomb's law we can write that Fe equals to K into Q1 Q2 divided by R square. By using this formula we can write that Fe equals to, here Q same charge, it will be same charge, so Q and Q, so it will be K into Q square divided by R square. Okay, K into Q square divided by R square, because this is same charge. So Fe equals to, K means 9 into 10 to the power 9 into Q square Q square divided by R square. R means 3.94 84 into 10 to the power 5 kilometer whole square. Okay. So from this we can see that two forces must be equal for reducing the gravity by Coulomb's force. So these two forces will be equal. So my dear students, from this calculation we can write that Fg, it will be Fg equals Fe, the gravitational force, and this repulsive force will be equal. So we can write here Fg means 1.98 into 10 to the power 26, okay, equals to Fe, the repulsive force is 9 into 10 to the power 9 q square divided by 3.84 into 10 to the power 5 whole square. From this calculation we will find out the value of q square. What will be the value of q square? Just we can do the cross multiplication. Okay. So from this cross multiplication we can write that q square will be 1.98 into 10 to the power 26 into 3.84 into 10 to the power 5 kilometer whole square divided by 9 into 10 to the power 9. So from this it will, by doing this calculation we can find out the q square equals to 3.24 into 10 to the power 27. So q will be root over 3.24 into 10 to the power 27. So q will be 5.69 into 10 to the power 13 Coulomb. My dear students, I hope all of you have understood this calculation and therefore the number of electrons we know. Now we can write that here this is the charge, okay, charge. So the number of electron, we know the number of electron, we can write this formula F equal to QE, sorry, N equals to Q divided by E, the number of the electron. This is the formula, N equals to Q divided by E. Q means the charge of electron, Q means the charge of this one, and E is the charge of electron. So Q, the value of Q is 5.69 into 10 to the power 13 Coulomb divided by charge of electron is, we know, 1.6 into 10 to the power minus 19 Coulomb. Okay, the number of electron will be, by using this formula we can find out the number of electron. Number of electron will be 3.56 into 10 to the power 32. Okay, 10 to the power 32. So this is the number of electron. Now we can find out the mass of the electron. Okay, so mass of the electron will be 9, and mass of the electron will be, we know the mass of the electron is 9.11 into 10 to the power minus 31 kg. My dear students, this value you have to also memorize. Okay, the mass of the electron is 9.11 into 10 to the power 31 kg. So the total mass of the electron will be, Mn. Okay, so Mn, that means 9 into 9.11 into 10 to the power minus 31 into 3.56 into 10 to the power 32. So it will be the total mass of the all electron. Mass of the all electron will be 324 kg. My dear students, here you have to memorize this formula. N equals to the number of the electron, N equals to Q divided by E. Q is the charge that is that we get 5.69 into 10 to the power 13 Coulomb divided by charge of the electron 1.6 into 10 to the power minus 19 Coulomb. So from this calculation we can find that the number of electron will be 3.56 into 10 to the minus 32, and the mass of the electron you have to memorize 9.11 into 10 to the power minus 31 kg, and we can easily find out the total mass of the mass of all electron will be Mn equals to 9.11 into 10 to the power minus 31 into 3.56 into 10 to the power 32, and by multiplication we can get that we will get 324 kg. So this is the mass of the all electron, and so if we can keep 324 kg electron both in earth surface and in moon, the moon would come out of its orbit. So my dear students, I hope all of you have understood this mathematical problem. Practice properly this calculation at home again and again, and I am giving you SW now. Today's SW number 1 and mathematical problem number 2 and 4. Number 2 and 4 will be your SW, and submit it on Saturday. My dear students, I hope all of you have understood our today's topic. Keep practicing at home. See you again in the next class. Allah Hafiz.